today. If you've joined for any of the previous webinars, it's nice to have you here again. We're looking forward to focusing more on ground source this time because we didn't have so much time to do so previously. So without further ado, this is today's webinar. It is recorded, will be emailed to all registrants following the webinar sometime later this week. So you can watch it back as needed. And just a couple of housekeeping points. If you do have any questions, there will be a question and answer session at the end. We will be doing our best to answer questions in the chat function and the Q&A function as we go through. If there's anything more involved, we will save it for the end and then open things up for more questions. If you are calling in today rather than joining on a computer, you can ask questions by raising your hand. Just press *9 and we will keep an eye on everyone. Next slide. Great, and I will turn it over here.
Good afternoon. Thanks, Ryan. Good afternoon, everyone. I'm the Sustainability Director for the town of Acton. Just before we get started, Ryan, would it be okay if we upgrade every attendee to panelist at the end so that we can see each other's faces? That always helps, I think.
Sure, happy to do that. And if anyone's not comfortable being on video, it will prompt you whether you want to accept or decline. So when we reach that point, if you'd like to join the group with video and we can see everyone, you can accept and join the panel.
Great, thank you so much. So I'm just going to give you a little bit of context of how we got here. At the town meeting on September 8th, 2020, with near unanimous approval, residents called to pass the climate emergency declaration. It specifically calls for net zero emissions as quickly as possible with a target date of 2030. Next, please. So what does net townwide carbon emissions to zero mean? Well, a big part of it is reducing the emissions in our buildings. So you can see at the top chart, those are community-wide emissions. At the bottom pie graph is our municipal emissions. And at the top, you can see how stationary energy, so the emissions from our buildings, which are made up of the green and the blue pie, make up a really big chunk, nearly half of our emissions. And that's why we're here today. We're here to discuss an important strategy for reducing emissions in our buildings. Next, please. So how did we end up with a BODE? So the town is in collaboration with the Acton Climate Coalition, and we have a site called Energize Acton. And one of the really important components that Energize Acton, the Acton Climate Coalition, spotlighted was electrification and transitioning to air source and ground source heat pumps. And so I've taken a little snapshot of the Energize Acton platform, which has a list of various actions that residents and businesses can take in Acton to reduce their carbon footprint. And one of those, which I've highlighted below, is the heat and cool transition to electric heat pumps for heating and cooling. Next, please. Oh, no, that's okay. I guess didn't make it to the, somehow it's not working, the images. I'll let you use your imagination. I had a picture of the Douglas Gates Elementary School and our fire station. So those are two buildings in the town of Acton that are triple net zero and are connected to ground source heat pumps. So they're heating and cooling is coming from geothermal wells, and they will not be connected to natural gas. So we're already seeing this shift in our municipal buildings, and we want to make it easier for homeowners, for residents, and also for businesses, for multi-unit housing to make the switch and adoption to air source heat pumps and ground source heat pumps. And with that, I will hand it over to the experts. Mike.
Okay, perfect. Hi, everyone. So if you were on the previous webinars from the towns related to air source heat pumps, I was the presenter. I'm going to just kind of give a little bit of context for why we're going to be talking about ground source heat pumps today. And one of the big things was There was a lot of interest on our last webinar about air source heat pumps, about, the sister technology ground source. So I'm gonna just kind of highlight some of the differences and how I think about the two, and when you really should be thinking that this this home in particular is gonna make a lot of sense to kind of start with focusing on geo as opposed to air source heat pumps. But I did also want to just give some really good news about Mass Save in the next 3-year plan and how the rebates and incentives are going to look like. Right now, if you're a natural gas customer in 2021 and you want to adopt air source heat pumps, right now the rebate has been just $250 per ton. And say for my own home and my own air source heat pump project, that amounted to a $1,250 rebate. So my project costs over $20,000, $1,000 rebate. It really doesn't go that far. The good news in 2022 for Mass Save customers for air source heat pumps, it's now, instead of $250 per ton, it's $1,250 per ton. But so that's thousands more in rebate and incentive money to help really bring these project costs down. The really exciting thing, if you do make a commitment to be getting off of fossil fuels and use air source heat pumps as your primary source of heat, your sole source of heat, you're not designing a system down to 20 degrees or 15 degrees, you're designing a heating system on air source heat pumps to get you down all the way to the design temperature. So I forget if Acton, if it's 2 degrees or 5 degrees or 7 degrees, but it's a little lower. You will be getting a $10,000 rebate. So do know that as you are thinking about heat pump technology on the air source heat pump side, do not, or if you've gotten quotes already for this and it was a little bit past your budget, do know that the affordability related to install cost is going to be certainly much more favorable. There's really great news with ground source heat pumps and incentives, but I'll let Larry go over the financials of how that all is going to work. But yeah, do know that the marketplace is going to be extremely much more favorable heading into 2022. And the other things that have been true and are still true today, if you do go to abode.energy/Acton, right on the front of the page is going to be a little pop-up that says you should start here. And if you click that, you will be able to book sometime 30 to 60 minutes with me or one of my colleagues to really review whether or not air source heat pumps or ground source heat pumps make sense for you and your home. So we'll be talking about existing mechanical systems, goals of the project, thermal envelope, where you are in the Mass Save program, how to take full advantage of the Mass Save program, how the Mass Save makes the system affordable. So we're kind of happy to be like these third-party consultants or homeowner advocates between you and all of these different programs that are running, but also you and contractors. So we can help you locate contractors, review your proposals, make sure everything's appropriate. So do want you to take full advantage of that as a resource at no cost to you. So real quick with, I think Larry's likely going to have other things to say over here as far as where he sees ground source heat pumps role in the Massachusetts marketplace as opposed to air source heat pumps. But I did want to just kind of document a few things about as far as how I see them, like why ground source heat pumps make so much more sense for certain people over air source heat pumps. So starting off, I'm pretty big in energy efficiency. Ground source heat pumps are a whole lot more energy efficient than air source heat pumps. So, at the end of the day, when it's 0 degrees outside, that air source heat pump is going to be working really, really hard to be bringing, negative 15-degree energy onto that 0-degree coil or whatever, having a negative 15-degree coil and 0-degree air passing over it. There's not going to be a ton of energy to be bringing into the home. Versus ground source heat pumps, they always have the benefit of just pulling that heat and that energy off of the ground where it's closer to 45 degrees versus 0 degrees. So they, when they are running as a heat pump, they're always going to be running much more efficiently. There's all sorts of different definitions of net zero here in Massachusetts, whether it's on-site or whether you're purchasing renewable energy credits from out of state to offset your electric bill. But one of the things that's true in Massachusetts, on-site renewables get a lot harder after you're doing more than 10 kW. So what that means, if you do really want to have one definition of net zero, like on-site renewables generating 100% of your load, for your heating, your cooling, your electric, like you really need to kind of shrink down either the demand of the house or how efficient the mechanical systems are to kind of make those numbers work. And really kind of ground source heat pumps is the easiest way to do it. Another big difference between, I think, air source and ground source is in 15 to 20 years, all of my ductless mini split equipment is going to be obsolete. All of the outdoor equipment, all of the indoor equipment, everything is going to need to be, an investment's going to need to be remade for all of that, versus ground source heat pump, where all of the outdoor equipment is going to be good for 50 or 100 years. The other thing, and this is just true for ductless equipment, the indoor equipment, that's same thing, 15, 20 years, it's going to be gone. But say with geothermal, most projects are going to be using new ductwork or existing ductwork. That indoor distribution system is going to be around for the next 50 or so years. So do know when you are getting quotes for ground source heat pumps that a lot of the investment is going to be long-term, and it's going to likely be tied not to just the heat pump that's going into your basement or up in your attic today, but probably the next heat pump after that as well. Other things that's true, so air source heat pumps, it's going to be much better incentivized by the utility programs in 2022. But with ground source, not only is there going to be really generous utility run programs to incentivize it, but also the federal tax credit is 26%. And that really does do a huge, that really does help drive the project cost way, way down. And a lot of the ground source heat pumps are eligible for alternative energy certificates, which is some further funding that helps make these projects affordable. For my own home, and this is a little bit complicated, but I just wanted to highlight probably the biggest reasons why people are preferring ground source heat pumps over air source heat pumps. And it really is, or ground source heat pumps as opposed to ductless mini splits. I have a handful of temperature sensors scattered throughout my homes. And what we see right now was the temperature in all of the rooms at 8 a.m. this morning. So do know that the ones that are in gray over on this slide is the system that I consider my primary. This system is really sized to help my home, is really kind of the primary heat pump that I'm trying to run. Because if I'm running this one, as well as my other outdoor unit, there's almost too much horsepower and the equipment will end up kind of cycling on and off. And it really does bring down its efficiency. So what I always try and do, and what I always encourage customers to do, is when you are trying to be heating with mini splits off of multi-zone systems, is to have some sort of a control strategy where you are trying to use one as a primary, increase the efficiency and the performance of it, and don't turn on your other unit unless one, you're uncomfortable, or two, you don't mind paying a little bit more in your electric bills. So just to put this in perspective, so with my house right now, this morning, you know, I had one room 66 degrees, another room 72 degrees. For me, that's no big deal. 66 is perfectly comfortable. 72 is where I'm kind of sitting throughout the day. I like it a little bit warmer. But for other people, if they do want to kind of have every single room of their house right at 70 degrees and to do it efficiently, you're going to be needing to go with like a ducted system versus mini splits if you do have like an older home with kind of like a very chopped up enclosed floor plan. So just to help you kind of understand some of the challenges and why I ended up going with ductless versus ducted is, say on my house, if you're looking at it in satellite view, to duct my upstairs, because I have dormers, I would need to have, and my attic is finished, I would need to have 2 separate heat pumps up there. I would need to have a third ducted heat pump down in the basement. Ductwork in Massachusetts isn't the most affordable place to get new duct distribution run. And just kind of using some rules of thumbs for other quotes that I've seen, I would think that ducting my first floor with an air source heat pump would probably be somewhere between $20,000 to $25,000. And for doing the second floor, because I would need 2 separate heat pumps in the attic, 2 separate distributions up there, I'd probably be looking at somewhere between 30 to 35K to do that. So my whole project, could easily be coming at $60,000 just to kind of get off of natural gas, get off of those steam radiators. And at the end of the day, likely would have been true that if I did get a quote for geothermal, I don't think my site is ideal for it with my driveway separating me in the backyard. I do think that there's a good chance that actually ground source heat pumps for my particular house would have come in, and if ducting and even temperatures was the priority, ground source heat pump would have lower operating costs. The house would have less kind of temperature gradients throughout it. So it really is like when you start kind of stacking on like architectural decisions, interior design decisions, ground source can really end up not only being much more efficient, but it can actually even become the more economical choice up front. A few things about why I wanted to bring Larry on to kind of talk about ground source heat pumps. And I do want to just make a note that the town of Acton doesn't explicitly recommend any contractors. But Larry's done a good job being a leader with with running a lot of municipal programs. So he's done a lot of work with the Heat Smart campaigns throughout the state. Other things that I think is really good about Larry is that he is one of the leading geothermal installers throughout the state. So Massachusetts has done a traditionally poor job of nurturing the contractor marketplace. So there's not a ton of people who've done a lot of work in Massachusetts, but Achieve Renewable is one of them. So I'm sure that there's a lot of real lessons learned throughout it. The other thing that I like as a building scientist, what I really liked is I was reviewing a proposal of his not too long ago, and he flat out designed the system for 54,000 BTUs, but the home's load was currently 77,000 BTUs. But there's all sorts of things that could be fixed and all sorts of things that could be done to be bringing down the building's load. Air sealing, insulating the basement are kind of like the 2 big ones that got pointed out. But in my entire time of doing this, I've never seen an HVAC proposal from any air source heat pump installers that say, I could be installing 60,000 BTUs worth of equipment. Sorry, let me rephrase that. Like every time I see an air source heat pump proposal, if the home's load is 70,000 BTUs, they're putting in 84,000 BTUs worth of equipment. There's hardly ever a discussion about actually like doing the easy fixes to bring down the load. And some of the fixes may be a little bit more challenging to achieve, but I do think that what Larry really is like in a building science, BPI way, everyone's always saying, take a whole home approach. And you shouldn't be designing a mechanical system around the inefficiencies of the building. You should be, fixing some of the inefficiencies and designing the mechanical system around that, because it's going to have lower operating costs at the end of the day. So all of those savings will be achieved. So I feel really good about bringing Larry to you guys today. And I'll be sticking around for the question and answer portion if anyone wants to get any insight about air source as well. So Larry, with all of that said, I'm happy to turn it over to you. I'll stop my screen share and I'll let you take it from here.
Okay, great. Thanks for your interest, everyone. I'll just pull up my presentation. And I'm going to discuss ground source heat pumps. My company does geothermal install exclusively, and we do have a focus on the whole home or the whole commercial building when we're doing our work. So the particular proposal Mike was just talking about, the heating load for the house was at a certain level. We came up with a strategy to appropriately lower the heating load with verification that that was happening, and then did a system design for the improved house. And that's a typical scenario for how we try to do our work, because ground source heat pump installations aren't cheap. And if you can do some air sealing, insulation, other weatherization, and have us put in a system that reflects an improved building, then that's going to be a more economical install. And as Mike said, is also going to have lower operating costs. So we can maybe talk about that further when we get to the discussion section. But today, at least as going through the slides, I'm going to discuss what geothermal heating and cooling is, how it works, what the components look like, to take some of the mystery out of it, a little bit about benefits, some discussion of pricing, and then we can have our questions and answers. Or at least we have the questions. I'll try to give the answers. We'll see how that goes. So first, what is geothermal heating and cooling? What I'm going to explain is that ground source heat pumps or geothermal installations provide increased comfort compared to conventional systems, operational savings, they're very reliable, reduce your greenhouse gas emissions, can be safer because you eliminate the combustion of fuel, which obviously has fire and carbon monoxide concerns. The systems are generally quieter than conventional systems, and as Mike mentioned, have a significantly longer equipment life. So hopefully your takeaway will be switching to geothermal will give you peace of mind. So the first thing you need is a volcano, or maybe not. A lot of people have seen the sciencey shows that might show Iceland or similar volcanically active area where they can drill a boring and get very hot water or steam and then just use that directly for heating. That's not what we do. So it's okay that the nearest volcano isn't very close by. We do an exchange with the ground. We harvest heat energy from the ground, just like an air source heat pump harvests heat energy from the outside air for the heating cycle. And then in the cooling cycle, we discharge heat to the ground. And because our ground temperature in Massachusetts ranges from about 51 to about 55 degrees, depending where you're at specifically, that's a nice moderate temperature that allows us to efficiently heat and efficiently cool. And most systems use vertical closed loop, which I'll talk about more, but it's in this cartoon. When you're providing heating to the house, fluid comes up through the piping we have underground, and heat is extracted and that's delivered into the house. One common misconception that people have is they confuse heat and temperature, and they're not the same thing. Even though we talk about turn on the heat or there's a problem with the heat, heat is energy and it can be delivered in a quantity, just like you can deliver a gallon of milk. If you put enough heat into a space, it will warm up to a particular temperature. So with ground source, it doesn't matter that the ground temperature is around 50 degrees. You can heat your house to whatever temperature you want, even temperatures a lot higher than people normally live in. in the cooling cycle, we take heat energy from the house and we remove that and discharge it to the ground. So the cycle simply reverses. Ground source heat pumps need three main components. We're going to talk about the ground heat exchanger in a minute. Then there's the heat pump itself, and the distribution system is important. And a lot of times in configuring a system for a home, it's important to consider what the distribution system is going to be at the beginning so that the right style of heat pump and the right configuration can be selected. So most installations are ducted heating and cooling, and we'll use ducting in the traditional way to provide warm air and cool air depending on the season. Ground source heat pumps are also very good and commonly used with radiant flooring. Ground source heat pumps can also be configured in a ductless configuration. So at Mike's house, when his new outside condensers crap out 12 years from now, he can put in a geothermal condenser and keep his same head units potentially. So even though he's on the dark side now, we have hope to turn him back to the light. Baseboards are possible, but really not commonly done. Ground source heat pumps can't make the same temperatures that a boiler will. If you have baseboards, your boiler probably circulates 160 to maybe 175 degree fluid through the baseboards. Ground source heat pumps top out at about 150 for the maximum, and that's only a couple of pieces of equipment can do that, and other ones are limited to lower temperatures. So the output of the baseboard is reduced. That's okay if you've done a bunch of energy improvements to the house and you essentially have more baseboard than you need. But you don't get to do cooling through the baseboard. So ultimately, people will usually pick a ducted or a ductless system because they want the air conditioning, especially in our warming climate. If you have radiators, that's just kind of a no-go as a distribution system. We can't approach the temperatures that are needed for radiators, so something else would be done. But again, even if we could supply radiators, you wouldn't be able to cool that way, so you might be inclined to move to one of the other options. So how does it work? How does a ground source heat pump actually provide heating to a house? We use electricity to power refrigeration equipment within the heat pump. That's a compressor and some valves and controls that move refrigerant around and evaporate it in one place and condense it in another. That process is the same as the way your refrigerator works, so it's not like it's magical. And if you use 1 unit of electricity, let's say a kilowatt of electricity with a geothermal system, that is not used to make heat for the house, it's used to harvest it from the ground. So if you picture the farmer with his combine harvesting the wheat, he's using diesel fuel to power the combine, but he's getting all that wheat in. What we get is heat from the ground, and that 1 kilowatt of electricity will let us harvest 4 kilowatts of thermal energy. And then it's just a quirk of the way heat pumps work that the waste heat from the equipment dumps to the hot side of the machine. So you do get the 1 kilowatt of thermal energy out of the electricity also, for a total of 5. In the air conditioning mode, we're pumping heat into the ground, and we're also pumping the heat from the equipment into the ground. But the ground source heat pumps are so efficient at cooling that extra overhead doesn't really matter. So here's this diagram again. We're in the heating season, we would be pumping our fluid through. It comes up warm from the ground, goes back cold, rewarms as it makes its cycle, and the opposite in the summertime. Comparing heating system efficiencies. And I want you to think beyond efficiency of the equipment and think about the efficiency of your dollar. So with an electric heating system, like an electric baseboard or an electric hot water heater, if you put a kilowatt of electricity into the hot water heater, you'll get a kilowatt of thermal energy. So what you get out is the same as what you get in. In heating and cooling, a common rating system is COP, coefficient of performance. And that's a simple ratio. What did you get out of the equipment? What did you have to put in? So with electric hot water, you've got 1 kilowatt out, you put 1 kilowatt in, your COP is 1. So everything that you bought in that 1 kilowatt of electricity, you get to use. In a fossil fuel system, that's never the case. You always have some of the heat going up the flue. Here we have a pie chart showing what you buy and what you lose with a 78% efficient, so maybe like 1970s, early 1980s fuel oil furnace, where you've got almost 30% of the heat going up the flue. So you pay for the whole pie, but you only get to use 78% of it. Ground source turns the table on that, because remember, we're only paying for the piece of the pie that runs the equipment. The rest of the heat energy we get is from the ground. So, you know, in a sense, we're stealing it from the earth. So we get out much more than we put in. So the coefficient of performance can be up to 6 with the ground source heat pump. So we can get up to 6 times as much out as we put in. And that is why the equipment is so incredibly efficient, is because you're not making the heat, you're harvesting it, and you're harvesting it from someplace that has it as a resource. You don't have to make it. So benefits. Well, cost is one. We've talked about that a little bit. And this is a chart I used 3 years ago, and then I stopped using it because with the COVID downturn, all the fossil fuels got incredibly cheap, and now they're back up where they were. So I get to use this slide again. So what this measures is how much it costs you to make 1 million BTUs out of each of these fuels. With the highest being propane, and note that that's a 98% efficient propane furnace. So this is how much it costs with the best propane system you can buy. Fuel oil is a little bit lower. Here we have an 80% efficient system. You can do a little bit better than that. So this bar graph could tweak up and down if you spent a little bit extra on your boiler. Air source heat pumps are kind of in the middle. These are for 16 SEER systems, which are typical of the ducted units. The mini splits like Mike has are a little bit higher, might get up to 19 SEER, so his bar graph might be a little bit lower than this. Natural gas, again, with the 98% efficient gas system, you're going to spend $18 or $19 for that 1 million BTUs. And then variable speed ground source heat pump system is around $14, $15 for 1 million BTUs. Now, to give you some sense of scale, the average house will use 80 to maybe 150 million BTUs a year. So you're making these payment differentials a whole bunch of times over the course of a heating season. Now, air conditioning is also much more efficient with ground source. That's not reflected on this graph, but that's an additional source of savings. All right, now I'm going to show a quick video. It's kind of a marketing piece, but it's only 20, 30 seconds.
What if just 20% of Americans switched to a geothermal comfort system? Well, it would save 43 gigawatts of peak electric demand. With those savings, you could power every home in New York, Vermont, New Hampshire, and Maine for an entire year. Comfort, efficiency, reliability. Contact your local water furnace dealer to learn more.
So that's a cool statistic of couple of times asked Water Furnace to change the ad because, you know, I'm a Red Sox fan and throwing New York in there kind of aggravates me every time I play it. But New York uses a huge amount of energy for their houses. So the other thing is that we could have many more states in the picture if we dump New York, which, you know, I'm lobbying for, but we'll see if I get there. Carbon dioxide emissions. These are examples of how many tons of carbon a typical 2,000, 2,500 square foot house might have as emissions with different heating sources. And the highest being electric resistance, if you get electric baseboard, but then the fossil fuels are all quite high. And then ground source heat pump for kind of an average efficiency ground source heat pump. Now here's the twist here. This is with grid electricity. If you buy or generate renewable electricity, this goes down and the greenhouse gas emissions can reach zero, either by the grid getting cleaner or you having on-site generation or purchase of renewable power. But natural gas, propane, fuel oil are never going to get better as far as their greenhouse gas intensity. So this differential can be a lot more than shown. This is kind of conservative, the way we've presented it. All right, benefits, you know, the environmentally friendly nature, the high efficiencies of the system, the energy savings. We will typically see 60 or maybe even 70% savings if someone switches from fuel oil or propane to geothermal. The savings are lower with natural gas because natural gas prices are pretty low right now, but that's changing as the economic recovery happens. Gas prices are going up. And probably will go up faster than electric prices, but we'll see. Eliminating the on-site fossil fuel use, as I mentioned, is important. It saves you from having those fuels present and also removes carbon monoxide risk. And then if you're into LEED or things like that, you can get points for doing something like that's really cool, like geothermal. Components. I mentioned the ground heat exchanger. These are pictures of the 4 types of ground heat exchangers that are used in the United States. The pond exchange almost never happens in Massachusetts because the municipalities typically own the water body, not the people with frontage. So you can't put a heat exchanger on something that's not your land. Horizontal systems are maybe 10% of Massachusetts installations because the digging around here is tough. The equipment and labor for digging is kind of priced high, and people usually don't have enough room. But in some places like Acton, it's possible to have enough space. Vertical closed loop is maybe 70% of installations. These are borings that are installed with the drill rig and have a closed circuit of piping. There's no interaction with the groundwater in these systems. And then maybe 20% of mass installs are standing column wells, which is a well that's designed kind of like an irrigation well. And in fact, sometimes we can dual purpose residential supply well and to be water supply and geothermal under the right circumstances and with the right approvals from the Board of Health. But vertical closed loop is what happens most of the time. And the equipment has the function of your existing heating system. So the form of the equipment is actually very similar. So these units towards the middle, you'll see a bottom section. That's where all the geothermal and magical components are. And then the top larger section is where the air handler is. It looks like a residential furnace because that's what it does. The unit all the way on the right would be a replacement for a boiler. So gee whiz, it looks kind of the same size and shape as a boiler. And then the units on the left are split units. If you had to have an air handler remote from the geothermal component, they can be separated. And these are for the ducted type systems or the hydronic systems that would be boiler replacements. The ductless systems have some similarity in the way they look to air source heat pump installs. There's what the manufacturers call an outdoor unit, which we actually don't put outside. It ends up in the basement because it doesn't need to be exchanging with outside air. And then you have distribution points that might be cassettes in the ceiling or wall mounted or console type. So that's the look of that install would be similar to air source. One big difference is that we run our refrigeration lines up through the interior walls of the house whenever possible. So you don't have that slim duct stuff that they try to make look like downspouts on the outside of the house. And then we talked about the various configurations, just reviewing. Ducted is the most common, but radiant and ductless are both very useful options. And then the hydronic options are usually not done. And then pricing. As Mike mentioned, we've done a bunch of municipal programs. We're doing one in Metro West now. And over the 4 years we've been doing those programs, we've developed a strategy that's a little bit based on how they make us bid these programs, but we've adapted it to make it pretty functional to any kind of installation. So there are base system sizes that have the heat pump and the drilling and certain assumptions, and then modifiers or adders that you can add or subtract from that to do things like have multiple zones on one heat pump or add domestic hot water, those sorts of things. And most systems do use some adders over the base price, but they don't have to. Financial incentives. Mike set me up for failure here, so let me see how I can do. Because I didn't put in too much about the 2022 incentives, because I don't like to promise things that aren't 100% official yet. But he gave me a get out of jail free card for that, so I will expound. So right now there's a 26% federal tax credit that applies to the entire installation. Some people interpret things like adding ducting as not being part of the installation. That's a question for a tax professional. $1 of tax credit is worth $1. So because you're reducing the tax you pay by not having a deduction. So you're actually lowering the amount of the check. The alternative energy credit program is in a little bit of oversupply right now. $1,000 to maybe $5,000 per home is typical, with most houses being on kind of the low end of that. A few years ago, that was much higher, and they're revising the regs. So starting next year, that may improve. We just haven't seen the final regs yet, so it's hard to make any predictions. MassSave has their $2,000 per ton of cooling capacity rebate up to $15,000. Currently, if you have an eligible electric account and you're switching from fuel oil or propane, I think Mike mentioned that that's changing. So people with any fuel next year will be able to apply. So it'll be easier to switch people off of natural gas and electric baseboard. The tax credit could become 30% next year if the Build Back Better Act is passed in its current form. So that would help a little bit more. But between the tax credit and the MassSave rebate, and then a little bit for the AECs and the sales tax exemption, our installations can be very competitive with other types of heating and cooling. And there's financing, and some of this will change too, when the new 3-year plan for MassSave is approved, which should be in January. Right now, you can get $25,000 towards a heating system install, and it's at 0% for 7 years. If you have a 2 to 4 unit residential, that limit bumps to $50,000. Mike actually pointed out to me the MassSave change for next year, which has the $25,000 for the heat pump, and then potentially $25,000 for weatherization, and potentially $5,000 for electric panel upgrade if needed. So that's a big difference in what's available at 0% interest. We have other financing options through industry organizations. For long term, the rates aren't great, but for short term, you can get 0% interest to help be a bridge to a tax credit or a rebate from Mass Save or something like that. And that's the last slide. So I'll stop my share and we can have questions.
Fantastic. Thank you, Larry. I was doing my best to answer some as I went through, but I can touch on those again just to make sure that those answers are out there for everyone. Looking through the chat here, Larry, I think you just mentioned this, but the 2022 rebates as they're currently written, I believe that yes, those are regardless of the fuel switch. So that applies to electric baseboard and gas and oil.
Right.
Great. Simon is asking, is vertical closed loop a possibility with most homes in the Acton area, or are there areas where the geology, water table, or other issues create challenges with boring down far enough?
Oh, that's a great question. I forgot to mention bedrock, which everyone always asks about. Most locations in Acton will be fine for vertical closed loop. The geology doesn't impact whether vertical closed loop can be installed or not. The drilling rigs are designed to drill through rock, and it's somewhat counterintuitive, but it's actually less expensive to drill through rock than through soil because they go slower through soil and have to set a steel casing to keep the hole from collapsing. And thanks to tariffs from the last administration, steel prices are really high. So drilling through soil is twice as expensive as drilling through rock. So we do like to hit bedrock pretty shallow if we can, so that we don't use a lot of casing. The things that will stop the vertical closed loop system from being able to be installed will be the presence of utilities like overhead wires, underground water and gas lines. If a property has a lot of slope to it, the drill rig needs to be level, and they only have certain limits within which they can level the machine. So if you have retaining walls and things like that, that can not necessarily stop the installation from happening, but it's something we have to look at because it can be more complicated. So it's more landscape features than geology is the short answer.
Great. And I think that more or less answers this, but we have a question here from Jeffrey asking, our home is built on a ledge. How does that impact the economics?
Yeah, potentially it's favorable. We like to hit bedrock as soon as we can once we have enough space to bring our piping into the building. So bedrock at 5-6 feet is perfect. Bedrock that's more shallow than that can still be accommodated, but then we have to do then we might do some things to relative to how the piping is installed.
Thanks. Stuart has a question about using ground source heat pumps for domestic hot water heating as well. Can you talk about that a little bit?
Yeah, it's certainly possible. The ducted systems can also assist a compatible hot water system and make the existing hot water system more efficient. The hydronic systems can directly address domestic hot water. My house has geothermal hot water as well as geothermal heating and cooling. So it's certainly something that can be done. The geothermal water systems are often more times economical when someone has another hydronic load that we're going to address. So if someone has some radiant flooring, we can put in one heat pump that'll handle the radiant flooring and the domestic hot water, and that it's sort of a two birds, one stone sort of perspective on that.
Thank you. Karen has a question here about on-site emissions of ground source heat pumps. That might be a question for Andrea more so. I know that you had plugged the renewable choice option there. And then I will just add that, with state mandates for grid sourcing, over time, the grid will be getting greener. So even if you're not opting into that, the on-site emissions will be decreasing over time. Okay, I think that sounds like that covers it. We have a question here about condos. I think it probably depends on the number of units and whether everyone's on board. But have you done any projects with condos, Gary?
We have, and it depends how big the condo development is and what the condo association is like as far as how easy or hard it is. We need to put in the ground heat exchanger, and that is typically installed on common property. So the condo association has to agree. So it's not real common that we'll do one condo. We'll usually do a series of condos or maybe all of them. And my lights are on a sensor here in the office and they just went out. So I'm going to wave my hands a little bit for a second. There we go.
Great. And just to build on that, I just saw a chat here from David saying that he just had a condo converted to geothermal. It was the entire condo that was treated through the condo association. So that's in line with what you just said. Oh, Mike had just asked, should we promote to panelists? I'd forgotten about that. So it looks like he's inviting people in here. If anyone would like to turn on their video, we'd love to see you and make it more communal. Oh, sorry, David's correcting me. It was just his unit that he did, but got approval from the condo association. My mistake. Okay, great. Looking back in the Q&A here. Karen has a question about if there's concerns about well contamination with doing the residential well system. I would imagine that that's some of what the health board approvals pertain to.
Yeah, the Mass DEP has policy that indicates that it's fine to do pending local board of health approval. Someone's drinking water supply we want to be careful when we're connecting to it. The strict requirement is that we have a certain location for the pump and the return line. By return line, I mean that the water would come out, go through the heat pumps, and then gets returned to the wells. So the well isn't going to be having a net removal based on the geothermal use. But it is also possible for us to put in an intermediate heat exchanger to separate the ground source heat pump system entirely from the well, other than for the thermal transfer. The concern really is if the refrigeration system were to breach. So with that heat exchanger, that refrigerant goes nowhere. Without the heat exchanger, it could go into the well. The refrigerant itself would evaporate, but there's a small quantity of oil to lubricate the compressor that would have to be addressed. So we typically recommend the intermediate heat exchanger when possible.
Karen also has a question about electrical panel upgrades. Is there a maximum to what a single residence could upgrade to, and is there any limitation as a result of installing ground source heat pumps, potentially along with solar and EV charging and whatnot?
I think I only sort of know the answers to that question because I'm not an electrician. As far as panel size, we normally don't have any issues with installations if people have 200 amp panels. If someone has a 100 or 60, that's likely to need an upgrade. But as Karen pointed out, when you have solar, that adds to the number of amps going through the bus of the panel, even though they're not coming from the street. And it sometimes when you have geothermal and solar and a house of a certain square footage, you need to jump to a 400 amp service, but that's not real common. but it does happen. So I guess in the perspective of the average house, usually 200 amps is fine.
Linda is wondering about sort of really general costs for what an average home, quote unquote, might look like for installing a whole home system.
Sure. First thing I'll say is there's no average home, and every home is different. So I'm already kind of out on a limb to start answering the question, but I'll do my best. If we think of a typical, say, 2,000, 3,000 square foot house that might have 1 or 2 levels. If we can use a single ground source heat pump, which means if the heating demand can be within the range of the heat pump, which in the example that Mike gave at the beginning of the report he reviewed, the house wasn't in that situation until the upgrades were done, and then it was. But assuming we're in a situation where we can use 1 heat pump, and we have that heat pump installation is probably going to have a pre-incentive cost something in somewhere in the 40s, maybe mid 40s perhaps for an average. But if you have to add ducting, that can easily add another $10,000 to $20,000 to the cost. In Mike's example, where he said, it might be $60,000, that happens to be kind of a middle number for our proposals, more or less. So if we look at that, if you have $60,000 and you get the mass save rebate for house this size, you'll probably get all of it. So you'll get the $15,000. So that gets you down to $45,000. You also have the 26% tax credit. And tax professionals will vary as to whether they take it from the 45 or from the 60. If they take it from the 60, it's around $15,000, $16,000. So that gets you down in the vicinity of 30 or maybe even a little lower. And that'll compare favorably to a house that didn't have ducting and wanted to put in air conditioning. So now, as I said, every house is different. There's all kinds of complexity as far as whether you need more than 1 heat pump or not. So this can be an illustration, but it's not even close to being a thought out proposal.
Thank you. I think that's really helpful for just getting a ballpark idea. Karen is wondering whether there are situations in which ground source heat pumps can't fully meet the heating demand. And then I guess you could touch on if there are any types of backups that you're ever incorporating as well.
Yeah, and she mentions the polar vortex. I hope the polar vortex stays away this year, but we'll see. When someone asks a question that's an absolute like that, is there any scenario when something would happen? Then the answer is always yes, because there's always, you can always come up with some scenario, even if it's incredibly unlikely. The root of Karen's question comes to the design of the system. There's going to be a design for a heating and cooling demand that's been calculated for the house. And if the equipment capacity is enough for that heating and cooling demand, then the house will meet heating and cooling requirements on a design day. And a design day is a particular temperature. It's the 99th percentile of temperature. And it gets colder than the 99th percentile of temperature. That's kind of obvious because it's not the 100th percentile of temperature. And so it does get colder that design day. So we typically install systems that have capacity above and beyond that design day requirement. But it is still possible for it to get really cold. I mean, the lowest recorded temperature in Boston is something like -37 Fahrenheit. It happened in early part of last century. But most of the time, it doesn't get more than a couple of degrees below zero. So in those normal cold snaps, the geothermal system should be fine. We typically install our systems with an electric backup, not with the intent of it being used for regular heating, but really in case something in the equipment breaks, that it can switch over to an alternate heating source. But those electric backups can be called if it gets really cold out, and a 50,000 BTU capacity heat pump can easily have a 30,000 BTU auxiliary on it. But the design should be done so that you're geothermal almost all of the time, if possible. And that goes down to having the right information for that heating and cooling load analysis. And some of that, it comes down to the homeowner being knowledgeable and forthcoming with what they know about the house. So it's a partnership between us and the homeowner to get the correct answer.
Great. We have questions here from Bryce and Fran, and I see Charles is raising his hand as well. So this question from Bryce doesn't mean a whole lot to me. Larry, if you're able to take a look at that, it may be something that's better for a one-on-one answer if it's pretty specific to the home, but I'll let you take a look.
The answer is really quick. Bryce asks if the radiant tubing for radiant flooring can be used for air conditioning. No, it can't. Not in our climate. That's been done some in very dry desert areas, but in our climate, you get condensation on the floor or within the floor, and so it's not good from a moisture control perspective, and also it's really uncomfortable to have cold feet and a warm head.
Great, thanks. Fran is wondering about changes, variability in gas versus electric prices, and how we're sort of forecasting, payoff periods and whatnot with heat pump systems. I don't know if Mike, maybe that is a question for you.
I have some deep thoughts on these, but one, natural gas is the majority of our grid. So kind of when gas heating prices go up, electric prices go up somewhat linearly. The big thing that I will say is in 2021 and in 2022 and all the way into the future, like on-sites renewable are a thing. The price of them is falling drastically, and that you don't need to be paying whatever Eversource or National Grid's wanting to charge you per kilowatt hour of electricity. So there's ways to be offsetting how much a kilowatt hour of electricity costs, but there's never going to be a way for us to offset how much a therm of natural gas is going to cost.
Great, thanks. And Charles, if you'd like to go off mute here, you're welcome to, and ask your question live. And that was Charles promoted here.
Can you hear me now?
Yes.
Okay, I was muted. Has any consideration been given to the possibility of ground source systems leaking and contaminating groundwater?
Yes, that's been considered. The antifreeze, or the three approved antifreeze types in Massachusetts, have all been evaluated by the Massachusetts Department of Environmental Protection and then approved by them for use. We use propylene glycol in our systems, which is a non-toxic antifreeze, and you'll find if you get your bottle of shampoo out, or even some of the foods you eat that are creamy, like salad dressings, you'll see that they have propylene glycol in them. So contamination from propylene glycol is not really too much of an issue. The other two are a glycerin-based antifreeze that similarly is non-toxic. And then the third, which from a performance perspective is the best, is an ethanol-based antifreeze. But ethanol, even though it's in a lot of things that people drink, can be a contaminant in the subsurface. But when a vertical closed loop system is depressurized, going from full pressure to zero pressure is something on the order of a cup of liquid. So you're not going to lose a lot out of these systems, even if one was compromised.
Okay, well, there's more to it. Are you aware that propylene glycol is also can be dangerous to animals?
I'm sorry, you broke up. I didn't hear the question.
I said, are you aware that propylene glycol can be dangerous for animals to be exposed to?
Well, I think that's more the case with ethylene glycol than propylene glycol. Ethylene glycol is toxic, and that's why people have switched to propylene glycol for antifreeze in vehicles and most common uses. I'm not aware of a health risk to animals from propylene glycol, but if you can share information with me, I'd be really happy to review it and maybe learn something.
It's deadly for cats.
Now, it's ethylene glycol is deadly for cats. I don't think propylene glycol is, but why don't we both check on that, because I don't want to be telling you you're wrong. I'm just, my understanding is different than yours, so we should both verify.
Thank you, Larry. I think David maybe had wanted to share something about his recent ground source installation, if you'd like to share.
Sure. I'd be happy to. It is under construction as we speak. There are contractors up in the attic putting in ductwork. But we have, I'm happy to say, our home at 3 Half Moon Hill is now being heated with geothermal. We could not be happier. I'll show you some pictures in case it's of interest to folks. This picture you're going to see is the front of the house. The house was built in 1735. Someone who fought in the Revolutionary War lived in this house. And that's one of the reasons we didn't want to use mini splits or air source, because we didn't want to disturb the appearance of the facade of the house for historical reasons. But we had other reasons too. We thought the performance of geothermal would be better. I like a warm house. Engineers told us we needed 2 closed loop wells. Each well was going to be 500 feet deep. I think that's something like 5 tons capacity. The house it's a pretty big, moderately big house, 3,000 square feet, but it's got a full basement, full attic. We also had to upgrade from 100 amp to 200 amp service. We had no duct work because right now we have hot water baseboard fired by gas. So it was determined we needed 2 heat pumps, one in the attic, one in the basement. We needed an easement agreement with our condo association because we drilled on common land. And the total project cost is huge because we needed ductwork and we needed a lot of landscape remediation. I am very happy, though, with the investment that my family is making in the future. This is the back of the house, and there's a lot going on. There's a community garden, stone walls, retaining walls. So we had to put these wells out in quite a ways, and that contributed to the cost because we had to come all the way down here to the house with trenching. So this is day 1. Trucks arrive, drilling rig arrives. There's the pipe prefabricated at Bill Wenzel's office up in New Hampshire. 35-foot drilling rig and lots of landscape work. There's the loop going into the ground, half a mile of pipes, the combination of coming out to the house and then 500-foot wells, 2 pipes down each of the 2 wells. This is from up in our balcony. And The pipes come into the house. They have to be covered a bit to protect them from the elements. And there you are. There's the all the drilling is done. It's now connected to heat exchangers. It's now producing heat through these ducts. This ductwork wasn't completed when I took this picture. And that's the payoff in my living room. Heat coming up from the floor, making me feel very cozy and not guilty when I turn up the thermostat. That's a big plus. The remediation was pretty extensive, but it was a nice job by John Rice of Inspirational Gardens. These were the other contractors that we used, and we used water furnace heat pump of the kind that Larry described. That's my slideshow.
Thanks, David. It seems like much ado about nothing when all is said and done. So uninvasive, the end result. But that's great. Thanks for sharing. I think it helps to have some real world example of what everything entails. So thank you. I think we may have one more question here from Stephen asking about the value of switching from air source to ground source. Think it depends on the timeline of when equipment was installed. I would personally argue that ripping out the air source equipment most likely isn't worthwhile until it's at the end of its life. But Mike or Larry, if you have any thoughts on switching from air source to ground source, be happy to hear it.
Yeah, my only comment is whether or not the equipment is meeting what the goals are. So a lot of air source heat pumps were sold that are not cold climate, that do have significant capacity drop-offs, that isn't going to get people off of fossil fuel. So if the equipment isn't meeting the goals of the homeowner, then probably not worth it. But I think that would just be my high level comment on that.
Great, thanks. Karen has actually, looks like David, if you want to speak up.
Oh, I just want to say, someone asked me if I'd send out the slideshow. I'm happy to do it. Why don't I send it, Andrew, to you, and then you can take it from there. That
sounds great. We can send it out along with the recording of this webinar. And I think we should wrap up here in just a minute. We've come up on the end of our allotted time, but Fran has, David, if you want to speak up.
One other question. Often these kinds of projects are viewed through the lens of what's the payback period. And I know that's a range, and maybe that's a bigger question than you can answer in the allotted time, but I wonder if you could speak to that.
Sure, and I think that sort of coincides with Fran's question here. If the town or other entities provide sufficiently long-term financing to achieve positive cash flow from day one, should the town set a goal of most homes on ground source rather than air source heat pumps? Maybe we can bundle those questions a bit.
Well, relative to the air source versus ground source part of the question, I'm obviously biased. So, of course, I think that should be the case. And financing, long-term financing is important, and we have that in Massachusetts for commercial projects, but not for residential. As far as the first half of the question, I think since it was kind of pasted together, I forgot, was it the payback was the other part of the question?
Yeah.
So there are 2 or 3 answers to this, and I'll briefly do each of them. In new construction, after the incentives, the payback is usually 0 years, because a similar quality ground source heat pump system in new construction compared to a conventional system, after incentives, we're usually very close. So it's immediate or within a year or so. In a retrofit, it depends on a lot of things. It depends on how old your existing equipment is, what your cost would be to replace that equipment, and other factors like whether you have existing distribution through ducting or other means, or if you have to add that. On our projects in general, we usually see retrofit paybacks that can be as short as 4 or 5 years, or maybe as long as 11 or 12.
You.
Yeah, and as far as the, I guess, like one payback on, as far as the air source heat pump side of this is, so I could have conditioned my entire house to meet 100% of my heat load for probably like $10,000 or $12,000. So like, would everything be comfortable? Would there be 5-degree temperature gradients at 5 degrees, or would it be 10 degrees? Like, probably. It'd be a lot more than they are right now. So one of the big things with mini splits in particular is that, like, if you do want to get off of fossil fuels, you do want to kind of lower your upfront investment. And if you do want to have a absolutely delightful cooling solution, like air source heat pumps is a very easy thing to go that's likely applicable for nearly all homes, because you don't have like so much site conditions to be worrying about. But yeah, I think that with there's certainly not one size fits all for, how to get off of fossil fuels or what's the best way to do it. And that's why I do think that, like, sitting down and talking about your home, your goals, for 30 minutes to an hour, and just really trying to figure that out, and then just try to like get you into the right camp, and then kind of work through the process with you as things start to unfold.
Great. Well, thank you all so much for being here today and for your engaging questions and contributions. We really appreciate it. Larry, thank you also for your expertise and your time today. We will be sending out the recording and the slides, as well as David's presentation later this week once it's been processed, and look forward to meeting with a lot of you to talk about your homes.
Thank you all so
Thank you,
much.
everyone.
And also, if you'd like to stay in the loop about sustainability initiatives, I encourage you to reach out to me via sustainability@Acton, and we can add you to the email listserv, so you can stay in the loop about things like this. Make sure that you're up to date on the latest with the climate action plan as well. So thank you so much, Ryan, Mike, and Larry. That was really insightful. I learned a lot. I also think it's great that Charles brought up that question. There's a lot of uncertainty around new technology. So I'm really glad that he posed a question about this, because I'm sure other folks also had questions about this. I've actually heard questions about the fluid and concerns about the fluid before. So thank you, Larry, for answering that as well. And thank you all so much again for your lunchtime, sharing your lunchtime with us. And thanks, David. It was great to see your experience.
Happy to do it. So on. Thank you very much.
That was a great addition, David. Thank you. And thank you everyone for attending.